Okay, so can you see my screen? Is it visible?
Yes, yes.
Okay, so we will start the session, and if you have any doubts or any queries in between, just feel free to pause me and you can ask questions because like I'm also traveling, so maybe my internet may not be that much good, and also I have a throat issue, so my voice will be a little bit husky kind of thing since I was traveling a lot. So if something is not clear, just let me know. I can actually help you to clear that topic. So today's topic, I think I've covered many sessions on the security and privacy issues which are there in the AI world. We are mostly focusing on chain of trust, which is on using the blockchain technology for the audit and secure AI systems. And since it is just like a 1.5 hour session, I'll try to include the major topics which are currently in the research aspect. Like we will not be having too much of time to go in depth, and then we can have some kind of discussions, and I will give some insights on how things are proceeding. So let me move forward. So why AI need the chain of trust? So there is an interesting article. Maybe you can search in Google. It's published by the OpenAI itself, like from the famous ChatGPT creators, understanding the source of what we see and hear online. So I think most of you are familiar with ChatGPT and similar kind of generative AI tools, and you'll be using many kind of AI tools in your day-to-day life for improving the productivity, for writing, for creating images, videos, even many other aspects relating to both your professional life as well as your personal life. So the need is like whatever data which is getting pumped onto you is still having some kind of opacity, or it is still opaque in its supply chain. Supply chain in the sense, whatever data you are training, what are the labels given to it, what kind of code, like the Python code or any kind of programming code you are using, the models which are coming, and from which kind of sources they are coming. So there are a lot of different things which are actually working in the backend. And as a normal user, okay, if you're a researcher, you will be able to go in depth and refer the papers and try to understand it. But for a normal user, there is still a lot of things which are still not completely clear, or there is some kind of opacity which is there in such AI supply chains. So the best example is like if you are referring to ChatGPT, maybe you can see, I'm not giving any specific example, but you can see many of the answers can have some kind of biasing, or can have some kind of prejudice interventions, which is based on what kind of data is being fed into such AI systems, or how the training is actually happening. So that is why there is no built-in way to verify the origin, integrity, or ownership of it, and it also breaks the reproducibility and accountability of such data. Say, for example, suppose we have like 1.4 billion people in India. So if the 1.4 billion people in India are creating their own credible data source and telling like Sri Lanka is a part of India, or Sri Lanka is actually an island of India, and if the data is getting trained on such a huge volume of data, then the AI systems, if they don't have a credible mechanism to trust, it will claim like, okay, Sri Lanka is part of India. Or even we have seen the controversial maps of many countries. Even the Indian map is also having controversial places. Same is the case with many other countries also, where based on the geographic patterns and based on the socio-political and economic factors, they will populate the data only on those aspects. So that is where we need the chain of trust and the post-hoc audits. That is how the logs are getting edited, or how they are getting deleted or fabricated. Because if we do some kind of machine learning training, or if we use some kind of machine learning algorithms, there are still a lot of parts which can be fabricated, or which can be actually treated in a negative fashion. The problem being, because currently most of these auditing mechanisms are centralized. So centralized means there is always a point where there can have like a single point of control. So if those people who are actually controlling can have some kind of bad things, or if they have some kind of negative impacts on the society, they can actually play with the data, or they can actually change the data. And the regulatory and academic audits depend on demand basically the independent verification, because primarily if you want to have some kind of credibility, there should be an independent verification beyond the skeleton of a core set of operators. So these are the main reasons why we actually need such a chain of trust for AI. And some more risk in that is data poisoning and model manipulation. So data poisoning means if once we have a data, and if we can have the same framework for the data, but if we can populate some kind of malicious or some kind of fake data for the training, the model weights and other inferences, the model can behave in a negative way, or the model's entire response can get changed. So which means we need to see who have actually changed the data, or where the manipulation actually happened, what kind of changes happened. All those things we have to get a track of it. That is why we need to have the tamper evidence. And tamper evidence means where the tampering actually happened and what kind of tampering have happened on it. And many of the worldwide European regulations, as well as the US regulations and many other countries AI regulations, which are used worldwide, actually goes for three main components: traceability, explainability, and accountability. That is, the new concept is like whenever you have a new AI algorithm or an AI kind of model is out there, it should be completely explainable in the sense whatever training is happening inside. Like you can have multiple levels of hidden layers or the deep learning kind of things. So there will be like some numbers or vectors which are actually running in the backend, but the user or the client should understand what exactly is happening. It should not be like a black box. It should be well explained to the user, and it should be responsible also. Say you have now, if you're using the generative AI tools like the ChatGPT, Grok, and many other tools, it should have a responsible AI. Like it should, whatever command or whatever prompt you are giving to the ChatGPT, it should have some kind of ethical and human elements in it. Like if I'm telling how I can kill some person, or if how I can create a bomb blast, so that kind of thing should never be encouraged, or you should not give a shortcut for it. Or if I want to do some kind of crime, and I'm asking ChatGPT, hey, I want to do some kind of crime in this country, suggest me some ways where I can actually escape from the law. So that kind of things should never ever be treated by the AI algorithms. That's why it have to be responsible. So these two parameters are quite important in all the AI models which are being out there right now, and in the coming era also. The explainable AI and the responsible AI are the key concepts which are coming out there. And what we are looking through this session is like how blockchain kind of technology can help in providing this chain of trust for such AI algorithms. I'm not claiming like blockchain is the only solution for this. There are many other kind of algorithmic interventions, but blockchain also have certain features or certain unique characteristics that can be used for ensuring the chain of trust. So please don't feel like I'm completely a blockchain advocate. I trust only on blockchain. It's not like that, because blockchain is only a technology enabler. I don't believe like blockchain will be the complete solution for all the problems which are there in chain of trust. There are many other mechanisms also which are carried out by the researchers out there. So just to give a very quick intro to blockchain, if there are some faculties who are actually completely new to this domain or who are experiencing for the very first time, I'm just introducing in a very fundamental level. If there are blockchain experts out here, please forgive me, because it's not a complete definition of blockchain. It's just a very, very fundamental thing. So in our computing world, generally we can divide the computing components into centralized and decentralized. I think in centralized, most of the computations happen only from a single server or only from a group of people who are actually controlling. It's called centralized. And the best example is your classroom, where there is a teacher who controls the entire class. So that is the best example for the centralized system, which means a teacher has the full control of the classroom and teacher can actually do whatever they wish. Decentralized means there is no single person to control the session, or there is no single person who will be taking care of it. Everyone have equal privilege. Just imagine like a classroom without a teacher. So all the students have equal privilege out there. there is no one to control them. They can either study, they can play games, they can throw chalk, they can draw, whatever they wish, they can actually do. So that is the notion of decentralized computing. And in case of blockchain, the blockchain is actually dealing with decentralized computing, because for the centralized computing, there are already many well-defined centralized architectures out there. So the blockchain is mostly focusing on the decentralized system, where without a central authority or without a central trusted agency, how the people can democratically, or how the people can equally participate in doing things in a better fashion. So that is what blockchain is all about. And maybe you have seen this image also, or it's like once you have a lot of data, a lot of transactions, you can bundle it together to the blocks, and when the blocks are sequentially chained together, it actually forms a blockchain. Imagine just it's like a storybook. So if you have a Harry Potter book, suppose I have around more than 200 plus participants here. Say like if everyone knows what is a Harry Potter storybook. So imagine if you want to read the Harry Potter book, you have to start reading from page number 1. Then only you can actually get the complete story. If you're missing the initial part, you will never ever get the complete story. Maybe you'll be making some assumptions, you'll be making some kind of assumptions, but it may not be correct. So the blocks forms the pages, and if the pages are sequentially arranged, it forms the complete structure, which is called blockchain. That is like the book. So it can be considered like your web series also, or even a movie series, where if you want to watch a web series which have like 5 seasons, you have to start watching from season 1. Otherwise you may lose a continuity, you may lose some kind of characters, and you will lose a thread. And the interesting part with blockchain is like every participant, just as I mentioned in the previous slide, the decentralization, here everyone is equal. So everyone have the same copy of the book, and the book is not a static one. Every other day, or every minute, or every second, a new data is getting written, and every book is getting updated. So it's like a continuously growing dynamic kind of storybook, where everyone have the same copy of story. So now you can see the value of trust here. Because if I want to break this trust, or if I want to attack, suppose I'm an attacker, I want to break the story. Suppose the block starts from block 0, 1, 2, 3, etc. Sorry. So I'm an attacker. I have like 232 participants here. All the 232 participants have the same Harry Potter storybook. If I'm an attacker, I want to attack something on block 1, which means I have to parallelly attack all the 232 participants and rewrite the entire block 1. But what happens is like this chaining happens with some kind of algorithmic called cryptographic hashing. I think maybe you all will be knowing what is hashing. Hashing is a one-way mathematical function which helps to verify whether the data is credible or not, whether you have at least even a single bit of data is getting changed, the hash value actually changes. So if I attack block number 1, the hash value gets broken, and the remaining block's hash also changes. So even if I am doing a parallel attack, still people can recognize, hey, there is some kind of malpractice happened, and the block 1 is tampered. So suppose there are 230 participants, I'm attacking only 5 people or 10 people. So the remaining people can tell, hey, there is a problem happening with the 5 people out there. For these 5 people, the data is getting tampered. So this is how the blockchain builds the trust for it. That is, everyone keeps the same copy of it, and everyone have the same pages arranged in the sequential order. So there is a non-technical definition of blockchain. I'm not going too much in depth into the technical definition, because our point is to move to the security and auditing part. So this means you have to have the same copy across the world. So imagine there are multiple kinds of blockchain here. The earlier versions of blockchain was only for cryptocurrencies like Bitcoin, Litecoin, and many other cryptocurrency versions. Then later on, there came the programmable blockchain versions like Ethereum is there, Near, Solana, Polkadot, and many other programmable blockchain versions, where you can build solutions on blockchain and release, just like the mobile applications or web applications. Now you can build blockchain applications. So which means globally you have the same copy. So even if the author of Harry Potter, J.K. Rowling, wants to change the story of Harry Potter, J.K. Rowling have to recall all the books across the world and then have to redo it and submit, which is quite computationally intensive in terms of the digital world. Okay, so that is why people started trusting blockchain, and people started leveraging blockchain as a a single version of truth in a distributed ledger technology. It is actually called as DLT, or distributed ledger technology, which is like a public source of information where nobody can directly come and tamper, or nobody can directly come and take down the whole data out there. And that is why the cryptocurrencies like Bitcoin and similar currencies were having a huge fan base, and people started using such kind of things, because cryptocurrencies are just one application on top of blockchain. Like why Bitcoin was popular is like it was a currency, but underlying the currency, they have the blockchain based ledger. So for example, if you're going to SBI, you have an account in SBI or any other similar bank, you have to trust the bank. Like whatever the statement bank is giving, you have to trust the bank. If bank is doing some kind of malpractice in the backend, like you have seen many frauds happening in bank, even in India also, like many of the top tier banks were doing many malpractices, but the common customers, they may not be aware of it. So that doesn't happen in blockchain. That is why people started trusting cryptocurrencies and similar coins which are running on blockchain networks. So we'll not be going to the cryptocurrency part here, because that is not our version here. We will see what are the key concepts which actually help us in building the chain of trust for the AI components. So first one is the provenance, that is the history of the entire data, which is quite crucial in designing the AI algorithms and training the AI models. As I already mentioned, for the blockchain, you keep on creating the pages to form the book, that is like blocks when arranged sequentially forms the blockchain. So it's like a documented lineage of data, models, and decisions which captures who created what, when, how, and from which sources. So if I am building a new AI algorithm for weather prediction, so I want to predict the weather, suppose in Delhi and the northern states, now there is a big issue with fog is there. So since the winter have started, we have a huge challenge happening with fog. So I want to analyze the previous 10 years historic data of fog and the winter conditions in New Delhi, and I want to predict whether there are chances of any smoke tomorrow. So if you know, like if smoke is happening tomorrow, if the air quality index is very low and the visibility is very low, the driver should be careful. You should not drive very speedily in the expressways or any of such roads. And the young kids or the elder people should not go out in the atmosphere if the smoke or the air quality index is very low, or there you have to use a proper mask, or proper medication should be taken for such things, or you have to, when you have to turn on your air purifier at your house, like which there are a lot of things which have to be taken care of if you want to design a AI model. So what if I'm going to build a model and I'm going to predict the weather of Delhi. But for predicting the weather of Delhi, if I am populating the data of the last 10 years from Maharashtra or from Rajasthan, maybe that data will not give you the actual results, or maybe they will have some kind of interlinking, but still you will not get the accurate things, or if there can be some kind of manipulations. So these kind of what do you call it? The text metadata and the text timestamping is quite crucial. That is why we want provenance, which blockchain can actually enable. We will see this in detail how it is coming in a later point of view. And like a data attestation, so there is no official or a legal attestation of data happening in the AI models, but if we can bring some kind of cryptographically verifying build statements, which means like a computational resistant state is genuine and untampered. Like if you are doing some kind of training, suppose you're training an AI algorithm with a data set for 50 epochs or 100 epochs, the user should also verify, hey, this algorithm was trained on particular data for this much amount of time with 100 epochs or 500 epochs or 2000 epochs. So because the problem is like, suppose maybe your algorithm will be good enough and giving a better result if you're training just 30 times or 40 times. But what if you're training like 500 times or 600 times, then maybe the results can get changed, or there can be some kind of additional weight training parameters which can also come into play. So that is the level of attestation which we want to securely store. And the third point is about the audit trail. It's like an append only. Append only means you cannot delete or edit or completely remove the previous data, but on a time sequence fashion, like on a timestamp fashion, you can keep on adding more and more data about the actions and the state changes. And inside the blockchain, inside a public blockchain, these audit trails will be completely independently verifiable, and it will be resisting to any the post-hoc manipulation, which means after training or after the model is created, you cannot change these data sets or you cannot change the audit trail. So if something went wrong in the training, that data is also recorded so that people can trust, hey, there was something wrong being happening in that training. You cannot tweak the data or you cannot change the data, because you have seen like in even in many of the well-known research papers and all, the researchers try to do some kind of malpractice or some kind of minute changes or minute tweakings to give the better results, but maybe on a long run this algorithm will not be suitable for that particular context. It will be only for the paper publication they'll be doing some kind of manipulations. And tamper evidence, as I already mentioned, if someone is going to attack, if someone is going to attack one or a couple of pieces of data, this is completely detectable, even though if it cannot be prevented, but you can actually see where the attack happened and what kind of attack have actually happened. And blockchain have something called hash chaining, which is also called a Merkle tree concept. So Merkle tree is nothing but a binary tree. I think you all know what is a binary tree. From the root, you can have a maximum of 2 child nodes, and it keeps on growing in branches. So Merkle tree is also a binary tree where all the nodes will be storing the hash value of the chain. So whatever hash is being computed in each and every block, as I shown in the previous image, these hash values are stored in Merkle tree, so that any kind of altering in AI logs, dataset or model records will have a proper cryptographic evidence. So just like if you're going to a court with some kind of digital evidence or a digital data evidence, the court will be checking the hash value of the evidence, like you're submitting a CD or you're submitting a pen drive or a mobile phone or a laptop. The court can actually check the hash value and see whether this is a credible evidence or whether you can actually take it as an evidence without any tampering. So the tamper evidence is quite crucial here. Yeah, please feel free to ask. I think there is a query. Sorry, can you please ask? Is there any question in the chat? Okay, if there is any question, maybe feel free to ask in between. I'm happy to take the question. Also, if I'm speaking a bit faster, just let me know. I will slow down because, yeah, Ranjita Krishnan, feel free to ask your question. If you're unable to, I think your mic is muted. If you can unmute and ask, or you can type the question in the chat also, if possible.
Participant can unmute their devices if they have any question.
Yeah, can you please ask the question? Oh, shall I? Is there any question in the chat? I think I'm.
No, sir, there is no question. Please
Okay.
continue.
Okay, so if there is any question, feel free to put in the chat, or you can also ask. I'll try to take the questions in between. And three more concepts, key concepts. Firstly, the verifiable computation. So whatever computations happen in the AI model, like if the algorithm is going to train or if algorithm is going to have some kind of computation, that can be it can be fully demonstrated with the proof. Okay, this is being executed in so and so way, and this is the way you are getting the results. And it does not require the verifier going back and doing the same process. Plus, there is something called trusted execution environment, which is called TEE. So TEE is actually not a dedicated part of blockchain, but trusted execution environment is there with many of the hardware secure systems like the Intel SGX boxes, ARM, and many other processors, where it can also be linked with blockchain, where they can enable some secure model execution, and they can give you the proofs for attestation, which can be again anchored back to blockchain. That is, it can be written in blockchain so that you can ensure the hardware which is being used for such model training and processing the data is also being securely written on top of blockchain. So that is an add-on thing, but it's not quite commonly used in all the scenarios. And finally, the smart contract audit policy, that is very interesting. So smart contract means self-executing programs which are running on top of blockchain is called smart contracts. Suppose if you have a business, suppose I'm running a Uber kind of ride sharing platform. So Uber have its own rules, and Uber will be creating all the business rules with the customer care policies and everything. So what if Uber is fully decentralized? There is no single party to own the Uber. Everyone across the world can use it, and it's like a piece of code. So they can create the business logic, they can convert it into a piece of code which is called smart contracts. That is why it's called the machine enforceable rules, which is encoded so that it defines who can record these events, what evidence is required, and how these computations or the verifications are actually getting performed so that anyone can run it. That is the beauty of smart contracts, which you can run only on top of blockchain. So that is why whenever you need an auditing of any kind of AI models or any kind of AI algorithms, you can use the smart contracts. So we will see these things more in more depth in the coming session. So these are the key concepts which I would like to start with. Beyond that, there are a lot of other topics also, but with the interest of time, we will be mainly focusing on these areas for this session, and maybe in future we can also have some dedicated sessions on that. Yeah, I can see one more hand raise. Is there any queries or doubts? Okay. So if not, I will just proceed. Before that, I will just take a pause. Just let me know if there is any doubt or any confusion till now. If I am going too fast, or if I'm too slow, or if I'm boring also, feel free to tell, because I just want to set the context. I just want to understand, like, we are focusing on the decentralized computing, not on centralized area, and we are trying to build the chain of trust for the AI models. Is it completely clear for you? Anyone, any doubt, any queries, any concerns? Feel free to ask. Ranjit, I can see you are still having a hand raise. If you have like any concerns or queries, feel free to ask or put in the chat. I can take the question. Okay, so if not, maybe I'll proceed, because I know I have to wind up the session in next 1 hour. So chain of trust architectures, like, okay, I'm not claiming this is the only kind of architecture which should be used for all the AI models. It is just one way approach of attempting to build the chain of trust for the AI models and creating the security. But there are many other mechanisms, and there are many other ways of doing it. But this is one way in which people are using blockchain networks and people are using the blockchain layers to build these kind of trust. So if you see the basic skeleton which I have provided here, on the top you can see the AI lifecycle. AI lifecycle is where the whole AI process is actually happening. Like if you're designing an AI model, and if you're training an AI model, you're getting the data sets. You'll be taking the data sets from the credible data stores. You will be training your model with your GPU machines or with a Google Colab or any other systems, and finally you will be testing it, validating it, and you will be creating your own model which can be used for the research purpose or for the business purpose. So you'll have the whole AI lifecycle which is actually trained, and this can be off-chain. Off-chain means it's not running exactly on top of blockchain. You can plug out completely as a different terminology. That's why I'm telling it's fully off-chain. So whether you are training a generative AI mechanism like ChatGPT or a similar kind of transformer algorithm, or whether you are focusing on any kind of deep learning algorithms, RNNs or CNNs or any other formats, it can have the whole life cycle there. That is right from the data ingestion, the pre-processing, the model training, model updates, inference, everything can happen off-chain. But why we want the chain of trust architecture is like we want to have the future architectures in AI, which can be heavily depending on the data model and the logs, that is the AI artifacts. That you want to have it to have some kind of a trust anchors. Trust anchors means how the data, the interaction with the model, and the logs created for training these models are securely trusted, so that the users of these models or the people who are actually interacting with these models will have a trust on such models. Because suppose you are building a RNN algorithm for me, how I can trust your RNN model, or how I can trust whether you have trained with the right data, whether you have provided the right kind of weight adjustments, right kind of modifications and everything to make sure that this work properly for the coming era. So that is where we want the auditing rules, or we want what kind of auditing which have to be done, and that should be working on top of the smart contracts. So which means, suppose I'm running a company, I want, suppose I'm telling I want to have like a weather prediction algorithm. So prediction, suppose I'm telling you want to use some kind of prediction algorithms or a regression algorithm or whatever you want. You can use deep learning also. But I'm not a programmer, so I'm not going to come and check all your code. Say all the 270 participants are building the algorithms. So what I will do is, like, I will write the auditing rules. Okay, if this is an algorithm, I have an auditing mechanism telling, okay, if this is a weather data, does the weather data have these parameters, or whether the AQI value is also there in the weather data, or whether fog or similar parameters, humidity, etc. is getting mapped on it, or whether this data have a timestamp starting from the last 10 years or last 20 years. Do they have a clear timestamp? Are they collecting the data every day or every month or every week? So likewise, you can have multiple audit rules, which as a business owner, I will be listing. So you will be creating the model and you will be coming back to me telling, hey, Adarsh, I have actually built an AI model. I have a wonderful solution which is running on so and so algorithm. You can pay me this amount of money and you can take my solution. So what I will do is, like, okay, thanks for developing this algorithm. Now I will be running my auditing rules via smart contracts. So it's on blockchain, so that nobody can tamper it, nobody can remove it. My auditing will be happening. Your model will get audited. It will be securely stored in blockchain layer. So I have the proof. So if you're trying to cheat me, I have the proof of cheating in blockchain, which means I can expose your illegal practices. I can expose your malpractices to the public on top of blockchain. But if you are genuine enough, if you are doing a genuine work to me, your genuine work is also exposed in a public fashion. So that means that the trust between the parties are more secure. Maybe like in even in social media and many other platforms also, people are afraid to tell the real truth, exposing their face, because they're quite a bit afraid, like, what if my face is getting exposed? So similarly, if you're completely genuine enough, you can actually expose your face and you can tell the truth. But if you are doing some kind of malpractice, or if you're doing some kind of illegal activities, you may be using some fake profiles, or you may be using some kind of fake inferences. So that is why we need this chain of trust kind of architecture. So behind the AI lifecycle, that is where that three green boxes comes into play. We will try to capture the provenance and lineage. We will have an attestation layer, and we will have a metal aggregation. So as I mentioned, this will be completely running on blockchain. Like, AI will be on top, and in the backend you will have the blockchain layer, where the provenance and lineage is nothing. It's the whole metadata which captures the origin of the data. What are the transformations? What are the pre-processing? All those kind of things you are doing on the data. And the versions of model, maybe initially you'll be using one version. You can change the versions in a periodic fashion. You'll have the hash of the whole code, like whether you have done the coding in Python or JavaScript or any other language. I will take the hash of it, because I want to make sure that you're not going to change the code in a future point of time. Timestamps and all the actors who are acting in the model. Say maybe if there are multiple actors, multiple stakeholders using on top of it, there should not be any kind of anonymous or a novel actor who is coming in a later point of time and trying to do some kind of malpractices. So all these lineages can be captured, and then we will have an attestation layer. As I mentioned earlier, you can have the cryptographic evidence of all the bindings which are out there. It can be either through the hardware attestation, like a trusted execution environment, where how this attestation happens is like, you will be checking on which hardware this particular model is running. Say for example, the Delhi Technology University have a AI lab, like they are having the most powerful computers and the GPU machines, and they have their own dedicated computer science or AI lab in it. So I'm mandating, like if a university is doing a work for me, a university is developing an algorithm for me, I will be mandating the trusted execution environment only within the Delhi Technical University lab machines. So I'll be verifying whether this particular execution environment is belonging to the GPU machines or to the servers within the DTU campus. If someone is running this algorithm and validating it outside DTU campus or at some different location, my TE attestations will not work and I will not take it. And we can have the digital signatures also, mainly to validate the people involved in it. Like if someone is trying to give the data, someone is trying to split the data into training and testing, someone is trying to create some kind of labeling out on top of it and all those kind of things, they will have their own digital signatures. Plus you can have the zero knowledge proofs also. So zero knowledge proofs, I think maybe most of you, if you have into the cryptography algorithmic part, or if you have learned about cybersecurity and cryptography, you may have known about zero knowledge proofs. ZKPs are nothing but if I am doing some kind of activity, I want to prove my work to a third party. Suppose you are the people who are actually verifying my work. So without exposing my real work, if there is some way in which I can prove, okay, I have a credible background in this particular mechanism, and I can actually prove that my validity is there, or I'm actually proving my anonymity. So I think maybe you have heard about the DigiYatra concept, which is there for getting the online boarding pass and going through the security gates of airports in India. I think around 15 or 20 airports in India are having the DigiYatra component. So DigiYatra is a kind of zero knowledge proof. I'm not claiming it's like a complete anonymous thing, but it's using some kind of blockchain mechanisms out there where previously, like if you have a boarding pass and if you have passport or any other kind of ID proof, if you go to the airport security gate, the CRPF officer or the army officer in the gate, they will be taking your boarding pass, taking your ID proof and check your complete proof. But actually there is no point in exposing your place, your gender, your father's name, mother's name, your age, everything to a person out there. You just want to prove you are the right person who is in the right ticket to get it. So that is what DigiYatra does. DigiYatra checks your proof with your Aadhaar biometrics, and without exposing your personal detail, it actually helps you to get in through the security check-in. So that is one way of doing it. Similarly, there are many algorithms like ZK Snark is there, ZK Stark is there. There are many similar algorithms out there which can give such kind of zero knowledge proofs for attestation. So we will have a final slide where we'll go for the zero knowledge machine learning algorithms which are currently being used in the machine learning world also. So moving on now from the provenance, we have the attestation, and then we'll move to the Merkle aggregation, where here what happens is, like as I mentioned with the Merkle tree, you will have the complete records of the provenance and the attestation which is being hashed and converted into the tree. So if you know the binary tree, I haven't included image of the Merkle tree here because it's nothing but a simple binary tree. So starting from the root node, you will have the leaves which keeps on growing level by level, which will be storing all the hashes and the attestation records in the blockchain. Which means even if a single bit of hash is getting changed, your whole Merkle tree will have that impact, so that you can easily catch who have done the fraud out there. Okay, so these three pros are primarily happening once you have the AI lifecycle. You can have the provenance and lineage capture, the attestation, and the Merkle aggregation. And after this Merkle aggregation, you have both the components, like you will be storing certain components in blockchain, or you can even store the entire components in blockchain. Plus certain components you can store off chain also. The reason being simple, because if the data set and similar parameters are extremely large in size, if you want to store in blockchain, it will be very expensive. It will be computationally very expensive to store the whole data set in blockchain. So what you will do is, like, the big data sets, the models, logs, everything you can store off chain. Off chain means you can either store in a database or in a cloud server or anything like that. And the references for it, that is, if you have like a content address references, these references you will keep track on the blockchain. So even if your data, suppose your data set is like 1 TB, so 1 TB of data, if you want to store in blockchain, it's extremely computationally complex. So you will store the 1 TB of data in a Google Drive or a Amazon Cloud Service or any other kind of mechanism, and you will take the hash value of that 1 TB of data. So the hash will be just 16 kilobit or something of that size, and this hash value you will store in blockchain. So in future, if there is any kind of change happening in that training data set, this hash value will never ever match, and you can claim like, hey, there is some kind of tampering happened in the data set, so you should not trust this source, or this source cannot be taken into consideration. So that is why there is a blockchain trust anchor where you have the immutable on-chain records. Why it is called on-chain? Because it is stored in the public blockchain, which is globally available. It's available anywhere across the world, as I shown in the decentralized computing figure. The best example is like if you have using the Ethereum public blockchain. For the Ethereum public blockchain, there are more than 15,000 nodes across the world, which means you have 15,000 copies at any point of time across the world. So it's quite difficult to attack it. Where you have the Merkle roots, as I already mentioned, the timestamp of the data, the issuer identities, and the policy references. That is, what are the kind of audit policies and who are actually issuing it. So that two components, as we've seen, the off-chain store and the blockchain layer, it keeps on storing the data. So the larger chunk of data goes to the off-chain store with the critical data identifiers storing in the blockchain layer, and both comes to the smart contract audit policies. That is the next layer where you can see the two yellow boxes where the smart contract auditing and the verification and the final audit also happens. So the smart contract audit policies, as I mentioned, is a programmable executable piece of code which will be running on blockchain, where there are well-defined rules, who are the authorized actors, what are the required attestations, what are the verification logic, and all other compliances. Like if this model is running in European context, Europe have its own platform called AI for Europe. So all the AI models in Europe which are running in Europe should be verified and validated by the AI for EU platform. If it's running in the US or any other different geography, they have to follow their own policies. And finally, we go for the verification auditing. That is, there can be auditors who can verify the integrity, which checks from the blockchain anchor to the Merkle proof attestation, and finally the hash matching. So if any kind of tampering is happening, or if any kind of mismatches are happening, this can be considered as a malpractice or as a fraud. Okay, so this is one way of ensuring the chain of trust, which is somewhat a quite popular approach using the blockchain mechanism, which is being used to ensure more credibility and more security and auditability for the AI lifecycles or for AI models out there. Any doubts or any queries till now? I'll take a pause here. If you have to, feel free to ask me if you have any doubts or any concerns or queries, or if anything I want to repeat also, feel free to ask.
So there is a question in a chat box.
Okay, I'll just do chat box. Okay, I think there are a lot of queries. Okay, so what is POW and POS? Okay, so in blockchain, there are many kind of, okay, POW means proof of work, and POS means proof of stake. So proof of work, proof of stake, these are called consensus algorithm. So consensus means it's kind of agreement between the parties. I haven't gone that depth in blockchain here because remember, you have Ajitesh have seen the diagram of the classroom I have shown. Like if it was centralized, there is a teacher and the students there. But in case of decentralized classroom, there is no teacher out there. So which means students can do whatever they wish in the classroom. So there should be a kind of agreement between the parties. So how it works is like what the majority of people are agreeing, based on that it will work. So proof of work was an early a consensus mechanism which is working on what kind of work you are actually doing. That is, it's mostly the computationally intensive work. For example, most of the cryptocurrencies like Bitcoin were actually following uh, proof of work. But later on, because proof of work needs a lot of computational power, which needs a lot of electricity and a lot of cooling mechanisms, everything should be there. Then came the proof of stake. Proof of stake means you will be staking some amount of money to make a claim. Okay, this is going to happen or not. So, for example, I am putting a stake of 1,000 rupees and telling tomorrow is Sunday. So if my claim is correct, if tomorrow is Sunday is being validated by majority of parties, then I will get my stake back. But you all know tomorrow is not Sunday, and I'm making a false claim, or I'm making a negative claim telling tomorrow is Sunday, which means my stake is lost. I mean, the 1,000 rupees which I'm putting is actually lost, which will be distributed among the verifiers or among the auditors of that particular consensus. Like this proof of work is just like if there are like around 200 participants here. I actually wanted to do an exercise on proof of work, but it will be quite complex in an online session. So if I'm asking some question, anyone in this room can actually answer the question, but whoever is answering the first and which answer is being validated by all the parties, there is nothing like a right answer or a wrong answer, but whoever is being validated by a majority of people, that wins the argument, and they will write the data into the blockchain. So both POW and POS were used for writing data into blockchain, where you need a consensus because there is no central authorities. And not only POW and POS, there are many other algorithms, but for the time being, I'll just give POW and POS. Hope it's clear for you. And yeah, chain of trust is like an end-to-end covering both hardware and other architectures. Yes, to certain extent we can include hardware also, but I would say even without hardware, just by using the public blockchain networks also, you can create the chain of trust. But it's always good to include the hardware part. Just as I mentioned, the trusted execution environment, it's good to include the hardware part also, because where the model is getting trained and what kind of infrastructures in which the data is getting stored, it's always good to have the proof of such kind of hardware also. So hope that answers your query. And how do proof of work, proof of stake, and PBFT differ in terms of security, scalability? Okay, so I think POW and POS I already mentioned. PBFT is another type of consensus mechanism, which is which was actually taken from the Byzantine fault tolerance mechanism. That is, at least n-1/3 nodes is running successfully. You can run the node. So mainly proof of work and proof of stake were used in public blockchain networks, while PBFT was used in permission blockchain networks like hyperledgers and all. So in terms of security, I would say proof of work is the most secure, even though proof of stake is also some kind of secure. PBFT can be considered secure, but you need large number of nodes to get it secure. If you are having just less than 3 or 4 nodes, PBFT is not secure. You need to have maximum number of nodes. Scalability, obviously, the public blockchain things like proof of work and proof of stake are easily scalable because they are public networks. PBFT is also scalable, but you need to make sure that you have the secure hardware to do it. Energy efficiency, I would go with proof of stake and PBFT because they are much more energy efficient, while proof of work is extremely energy consuming algorithm. That is why now people are trying to move away from proof of work, because it's taking large amount of energy to run these kind of huge algorithms. Maybe if you just Google it, you can simply Google the Bitcoin mining farms. Even the Bitcoin mining farms are larger than the big IT parks out here. There are huge mining farms in China, Korea, and many other areas where they are mining Bitcoin. But in our scenario, if you want to set up a mining rig like that, we need to burn large amount of electricity. Plus, we want to make sure that there is a good cooling system also out there, so that our machineries are not burning out too. So hope that answers the query. And what kind of auditing rules will we frame? Is it like checking the model parameters incoming? Yeah, exactly. So that depends on what kind of model you are going to train. Say, for example, if I am working with the energy data. So for the energy data, there are ESBs and energy controlling unit where they have their own auditing principles based on the energy data. If you're working on the weather data, or if you're working on something similar to that, there are well-defined AI catalogs which mentions what kind of auditing have to be done if you want to take this particular model for a public use, or take this particular model to kind of a commercial use. But for the activation functions, I think these things are mostly on the research aspect. Of course, it's good to have an auditing on top of it, but I don't think it's because you cannot initially define all the auditing principles for such activation functions. As I mentioned with the explainable and responsible AI, these things have to be coming back from the part of the explainable and responsible AI part. And every node will have a Merkle tree. Yeah, exactly. Every node can have their own Merkle tree. Large data can be stored on blockchain. Exactly, it can be stored on blockchain, but it will be very expensive. Like you will blockchain is not considered as a big data store or like a huge data store. You will be storing the hash of the main data, or will be storing the crux of the data, like the timestamps and the cryptographic hashing, only on blockchain to make it more simpler, so that if any kind of malpractice happens on the data, or if any kind of illegal activities happen, you can easily trace out. So that is why to support blockchain, there are many distributed and decentralized storage mechanisms, like IPFS is there, StoreJ, Filecoin. There are many decentralized and distributed storage mechanisms which you can add on to blockchain. Plus, there are many blockchain oracle services which helps you to gain such information. So that you don't have to worry about storing huge amount of data on blockchain. So hope that answers your query, Dr. Deepa Naik. And the next question, what if we are storing the data on cloud server like off-chain and using blockchain for access control? Is that data immutable? If yes, how? Yeah, so you can store data on cloud servers just like Amazon, the AWS, GCP, and all such major cloud service providers. They are also even helping you to run the blockchain instances, so that you can take the data off chain and secure it with the cryptographic hashing, so that you can connect it with any public blockchain network and see whether your data is completely immutable. And so it's quite possible with most of the public blockchain networks which have integration with such cloud servers like AWS, GCP, and all. It's doable. And the next question, how we segregated our large data sets, any algorithms or any refined mechanisms. I couldn't completely understand that point. If you are mentioning about data slicing and data recombining, I think it's a different concept. It's not directly relating with it, but in our case, whatever be the kind of data set, how large is the data set, or how huge is the data set, and whatever be the number of data set, it doesn't matters for the blockchain. Whatever kind of algorithm you are going to use to refine it or use to pre-processing, also that also doesn't matters, because as I've shown in the architecture, it actually the AI lifecycle is a off-chain thing, and we are doing the things in a separate layer. So that doesn't directly relates to our chain of trust. And if you store large data in Drive and create one hash that is stored in block, as you say, how it works. So how it works is like, if you want to validate the authenticity of that large data, suppose you're storing a large data in the Drive, and this large data is being frequently called at any moment, or it is being used at any instance, you will be checking the hash which is being stored in the block. Suppose you have created a data, a huge data in a Drive at 6:51 p.m. So if the data is created at 6:51 p.m. and you are going to use it 3 days later and you want to see it, you will be checking whether this particular timestamp is exactly the same, or if some kind of malpractice actually happened. If it happened, you can go and trace the thing if it is already there with an audit trail. As I mentioned with the chain of trust, you will be having the complete auditing of that large data set also. It's not like you're just writing the hash value, you will be also creating the entire audit structure. POW and POS, is it used in any particular state industry base? So most of the proof of work algorithms are used with the cryptocurrencies, and most of the proof of stakes are used obviously with the real world blockchain applications like managing the educational certificates, the healthcare data, the banking applications, and all those kind of things. Like now the Ethereum blockchain network, which is which was early following proof of work, now it's actually following the proof of stake. So I think the current networks like Solana, Polkadot, almost everyone is following some kind of modified version of proof of stake. So proof of stake have multiple versions, like delegated proof of stake is there, distributed proof of stake is there, pure proof of stake is there. So a lot of different flavors of POS is there, which people are using with blockchain. And who will frame the audit rules and who will validate? Except that's a very, very good question. So the audit rules which are there for controlling these AI models, as I already mentioned, this can be created with a smart contract, so that those who are actually participating in the network, they can actually verify and validate these rules. And as I mentioned, with the consensus mechanism, if if the majority is not approving with these rules, or if the majority don't want to have this particular thing being done, then this audit rule may not go out there. Or if in another case, suppose there is a business consortium, or if there is something like, okay, so for example, for the banking scenario, there is something called a banking.
Excuse me, sir. Your PPT is
Yeah.
not very visible, sir.
No, I'm not showing the PPT. No, I'm just taking the questions and answering it, because if I'm taking it full screen, I'm not able to see the chat. So I'm just taking the questions from the chat and answering it. Okay, I'll restart the slide soon. Okay. So for the, oh, maybe I'll share my screen also, because I think you are not able to see the queries. Okay, so I'll share the screen. Okay. Sorry, 1 minute. Okay, so now I was actually taking this question: who will frame the audit rules and valid? So as I mentioned, this can be done with the smart contracts, where all the stakeholders who are in the blockchain, they can actually validate and verify these audit rules. If not, if it's a pure business consortium, say for example, for the banking consortium, there is a consortium called R3 consortium. R3 is mainly a kind of blockchain consortium which deals with the financial institutions. So they will be focusing on solutions which are only needed for the banking and financial solutions. So like this, if there is a kind of consortium, the consortiums can also set the audit rules for the AI algorithm which are needed for that particular a particular use case. Okay. And in reference to the early question, the data is stored on cloud and only blockchain is used to access control. How is it making data immutable? Okay, so if the data is stored outside the cloud, the blockchain will never make the data immutable. Only the data which is inside the blockchain is actually immutable. The data outside the blockchain will never ever be immutable. That is what I mentioned. It is if you are storing the data outside, the hash in the blockchain will verify whether the data is getting tampered or not. So that is the trade-off which you have to take. Like if you have the bandwidth enough, or if you have the computational capacity to keep all the data inside blockchain, that is fair enough. If you're storing all the data inside blockchain, it is completely fully immutable. But if you're storing the data outside in a cloud, you can take the hash of it, and you can claim like, hey, this hash is getting changed, so I will not trust this data, I will not take it. So I'll give a scenario also. Suppose just like the weather prediction data which I shared before. So if I want to train the whole mechanism on the 10 years of previous weather data, so if someone is trying to tamper with the weather data, I can simply verify like, okay, if my hash value is getting changed. If my hash value is changed in that external service, then I will not consider that particular AI model, because I know there is a malpractice out there, someone is going to tamper it. So it's the responsibility of the developer, or is the responsibility of the company who is providing me the solution, who want to make sure that that data is secure out there. Oh yeah, okay, PPT, I'll do it. And any examples of audit rules? Okay, for the sorry, for the auditing rules, how it works is like this audit rules will be like a code infrastructure, and how it have to be run is it should be on a language called Solidity. So Solidity is a language. Maybe I will just show you the ID for running it. Maybe at the end of the class, maybe I'll show the ID because it may take some time to load. There is an ID, online ID called Remix. Remix is used for writing the smart contracts in Solidity language, where you can actually write the rules and you can create the audit rules for it. So the framework mostly this happens through the Solidity programming language. Can there be a group of miners? Yeah, obviously there can be a group of miners. It's possible. Individuals can also become miners. It's a choice of the user. They can either form like a group. But if you're forming a group, there should be set of rules for the groups, because if a single group is getting more powerful, then the other individuals may not be able to participate in that. So any other queries, or shall I move forward? Okay, so maybe I'll move to the slides. So my slides are visible. Okay, so now as you mentioned, maybe I'll go to some of the low level primitives which are critically needed for these things. Yeah, I think there is a hand raise. Any question? Any doubts or any questions to clarify? Okay, so maybe I'll move because we have just half hour left. So as the anchoring patterns I mentioned, you keep the hash of the data in the blockchain, then you can create the Merkle root, that is the binary tree structures, and you keep on. Sorry. Okay.
Sir, please
And you
continue.
create. Yeah, okay. And you create the blockchain transactions. So here the key points are, as I mentioned, you will have a one-way function, a one-way mathematical function, which is the cryptographic hashing. I think you're familiar with many of the hashing algorithms like the SHA algorithms and similar algorithms. Even blockchain also use SHA to physics hashing mechanism. As you know, it's having collision resistance, which means the same hash will never ever be repeated, and you cannot get back the initial value from the final hash. It's just like a one-way function. It can never go back, and it can detect the any kind of tampering. Like it's like a fingerprinting for the data sets, the model weights, logs, and the provenance. So you will have like a credible mechanism to make sure that there is no kind of alterations or no kind of tampering in your models weight or in your data sets or in your logs. And the digital signatures, as I mentioned, it is to prove the authenticity and accountability. Like if you want to exactly match this hash to an identity, as you ask whether the solution is for a business or for any kind of research purpose. So it can be either a human being or an organization or a group of users or a group of system. So it can have its own digital signature either through the trusted execution environments or a hardware mechanism, which ensures only the authorized users can submit the AI provenance or the history of the data is properly getting monitored. And the Merkle tree, that is where the entire hash structure, where you will be storing the many records into a single root. So it's just like a binary tree. So with the root, you will have all these components which are being listed, so that you can anchor thousands to even millions of AI events. So the tree can grow to any number of levels, which all anchors back to the same root, so that suppose say you have a new algorithm, like you have an adversarial network, like a GAN is coming. So you can have multiple versions of GAN, but all the GAN networks or all the multiple GAN networks or the all adversarial networks will be initially focusing to the root adversarial network or a root adversarial algorithm. So you can create the whole Merkle tree structure out of it. And the timestamp timestamp is not a unique feature of blockchain. Even within a database also you can have the timestamps. But for blockchain, timestamps are actually mandatory because all the block creation happens with a timestamp, where you will be having a global immutable ordering, because all the nodes are completely decentralized and distributed across the world. So which proves the dataset, model versions, and the decisions out there, and they will also prevent the backdating and the post-hoc fabrication. Like after the model is created, you cannot change a different evidence, or you cannot tamper with that data at a later point of time. That's why we always take the timestamp. And since the network is global network, you cannot actually compare with the current time of a specific geographic area. So we'll be directly mapping onto the GMT time for the timestamping. So these are the four important primitives, which are the key parameters of the blockchain, which we will use for creating the chain of trust. And now we'll be moving on to the integrity and confidentiality of building blocks, because as I mentioned, once we have such a technology running in the backend, how we build the integrity for the network and how we make sure that there is a proper confidentiality. That is why we have the add-on component called the trusted execution environments, or TEEs, which is like a hardware isolated enclaves which protect the code and the data during execution. Like if you are running a code, as I mentioned, I want to make sure that this algorithm is running within the Delhi Technical University's computer science lab within a specific server. It should not be running outside any of the premises. So I can ensure like, okay, did you have proper firewall? Did you have proper network security? Did you have proper cybersecurity infrastructure? So that all my training happens within that particular hardware. And this can enable the trusted collection of AI provenance. And as I mentioned, what kind of code is being loaded, what is the execution environment, and what is the input output binding. Suppose I am writing a Python code. I want to make sure that this Python code should be run in Python 3.1 with so and so dependencies and so libraries. And this is the kind of input which is coming if I'm taking the input from an API call, or if I'm taking the input from some real time data set, what kind of output it is going to give and where the output is going to get stored. So that is the confidentiality of the entire model parameters and inputs during execution, which is having the integrity of all the logged AI events. So that is why people started trying to incorporate such kind of TEs along with blockchain. But again, there are some limitations out there. Like there are still many contradictory theories telling even the Intel SGX box can be compromised, or even the Intel SGX box can be attacked when the quantum level computing and similar things can come. I'm not an expert in the hardware side of it, but this is just like an add-on component, which still there are a lot of conflicting things and researchers are actually happening. Even the quantum secure kind of trusted execution environments are already getting developed in that way. So that is why the limitations, there can be hardware trust assumptions, whether you trust Intel SGX or a different brand, that's your choice. And it's vulnerable to the side channel attacks and the limited enclave memory. So side channel attacks are something which can actually create the similar kind of scenario, giving like a virtual way of thinking. You are in the same scenario, but you will be giving a entirely different scenario, just like an eclipse kind of attack. But as I mentioned, this is not the core part of blockchain. It's just an add-on component, which is still under heavy discussions and heavy research. And then comes the zero knowledge proofs, which I mentioned. The ZKPs are much more algorithmic proofs, which verifies the inferences without revealing the internal details like the model weight. If I've used a model weight as 1.5 or 0.7 or anything, without revealing the model weight, but if I am able to prove something like that. So that is where the zero knowledge machine learning algorithms are coming into play. So I'm not going too much into the ZKML algorithm, because if I want to take an algorithm, it will take like at least half hour to 45 minutes to explain one ZKML algorithm. But if you are a researcher, or if you are dedicatedly working too much deep into zero knowledge proofs, you can refer the adaptations of ZK snarks or ZK stark, which were the general purpose zero knowledge proof algorithms, which the researchers are now trying to fine-tuned dedicatedly for the AI algorithm training. That is, it reveals nothing beyond the claim result. That is, what exactly is a model's result. It makes sure that this result is getting exposed without revealing the further details. But it can actually prove whether the inference was computed with a specific model and the prediction have the satisfied fairness. So there are many mathematical ways, just as I mentioned with the Digiyatra example. Digiyatra is a kind of a simple example for a zero knowledge example. So similarly, there are many sophisticated mechanisms which can help you to ensure the fairness and accuracy. But there are limitations because the prover cost is high for larger models, like the computations will be very complex within zero knowledge proof, and it requires the model compilation into arithmetic circuits. Like if you have a very big network like a transformers or a RNN or a CNN kind of network, the whole working of the transformer have to be verified within the zero knowledge proof. So that have its own challenge. So comparing the hardware side with the trusted execution environment and the algorithmic part with the zero knowledge proof, the TE actually protects the execution while the zero knowledge proof proves the correctness of the algorithm. The TE is actually the runtime integrity because it ensures the runtime integrity with the hardware. But the ZKPs are actually the post-hoc verifiability. That is, once the model is working properly in a hardware or in an environment, it can prove my model have worked properly without revealing the complete details. TE, as you already know, it's a hardware trust, but the ZKP is a cryptographic trust. So, sorry. There is no single mechanism telling, okay, you have to use both TE and both ZKP, because it depends on the time and money which you can actually spend on an AI model. Like, okay, if you are working on something like a very secure environment like a DRDO project or something similar to that, where you require dedicated hardwares and high security computations, you can obviously go for the trusted environment execution environments with the ZKPs and all. But if you are dealing with a general public data set which is available in Kaggle or similar thing, or if it is like a weather data set, maybe the weather data set may not be as much critical or as much crucial when compared to the military data set or something. So you can either avoid the TEs, or even you can add just like a ZKP or a smaller version of it, just to ensure the integrity and confidentiality. And finally, I think there were some queries like how the smart contracts will come into play. So smart contracts is a new way of setting the auditing policies, just like in the previous Web 2 world where you have the digital solutions, and finally when you're filing a taxes or when you're filing the what do you call the profit loss statement of your company, you want to go to a chartered accountant who will take care of your profit and losses and who will take care of all the final auditing process. The smart contracts can enforce all these business logic into a piece of code which runs on blockchain, not on individual machine. These smart contracts will be running on public blockchain, so that anyone across the world can validate the smart contracts and ensure that, hey, this business is running with the help of this smart contract, so that it can be trusted and validated. And if there are some kind of, it's just like an open source kind of thing, so that more and more people can come and validate and make sure that it is much more proven kind of mechanism. So it can also enforce who can actually append the records, who are the verifying anchors, the trigger alerts, and if there are any kind of SLM mechanisms or other audit rules, you can actually do it. And it can have an executable governance also, like if the AI systems, as per the AI catalog, if you want to have some kind of specific governance for the system, say like from which data set you have to train the model, or what kind of APIs you have to connect, what kind of external data sources you have to connect, that you can also mention with the smart contracts. As we mentioned, the authorization defining who can append the provenance record, like if there is some way of a role-based access, who is a data provider, who is a trainer, who is an auditor, and who is a regulator. And for the verification, which validates the submitted anchors, like, okay, do you really have the Merkle roots out there? Do you have the digital signatures? Do you have the attestations? And it can actually reject the records if the cryptographic evidences are not there. So which means if you're storing the data outside, or if you're interacting with some data from outside, you can easily go and check the verification without any manual intervention by directly using the smart contracts. And you can have things like a review, rollback, or freezing. So if there are some unwanted or malicious or anomaly kind of situations are happening, the smart contracts can trigger an alert so that you can be careful, like your model is going to face some kind of backlash or your model is in trouble. You have to act immediately and you have to take some good decision if there is a manual feedback or a manual loop is actually included. If not, the smart contract will itself have the decision making, like if the model is misbehaving or if the model's behavior is going out of control, maybe the smart contract can have like a self-destruct button or a self-kill button where it will completely stop the AI model out there. That's also a kind of possibility. So now we have the three trust blueprints for AI systems, which are the three separate research tracks which people are working on. First one is the data provenance anchoring, as I mentioned, mainly on the dataset manifest. That is, you will have Merkle rules on permission chain, mainly when you are dealing with the data which have the GDPR constraints or the personally identifiable information, that is the PII. Say like if I am having any information like my address, my gender, my blood group or something, suppose I have a driving license data set. So from the driving license data set, there are a lot of PII components, that is the personally identifiable informations are out there. So what you have to do, I mean, it should record dataset lineage without exposing the raw data, and it should capture the source, consent, and the transformations. So these are the anchoring points if your priority is on data provenance. And how you do it, you can generate the data manifest, that is right from the metadata. Metadata means what is the structure of that data, and if the file has some hashes, you create the whole Merkle root which goes to permission ledger. So why I'm not calling blockchain here and instead I'm calling a permission ledger, the reason being simple, because there will be some people or some machines out there who will have the permissions to write data, because this is an AI model or this is an AI scenario where there are people who have the authority on dealing the data set or dealing the AI model or on dealing the weight training. So those people will be the decision maker, or there will be similar people, similar stakeholders who will be doing the decision. That's why I'm changing the name to permission ledger, because it will be mostly depending on that permission or the access rights out there. And why? As I already mentioned, the data should never leave the institutional control, mainly if there are some GDPR or PA aware data set. And it should also be, mainly it's suited for the healthcare, academic data sets and other regulatory industries where you need to have the data provenance anchoring. So this is one kind of trust blueprint which is there for the AI systems, primarily working with the healthcare, academic data sets and other regulatory industry. And the second one is mostly on the on-chain inference attestation. That is where the actual working happens on chain within the blockchain. It's not taken outside the blockchain, or it's not taken in a different data set. Every working happens within the blockchain term. So there you can have like a model identifier, that is, suppose say there are 150 participants and all the 150 participants are creating a convolutional neural network. So you all will be having your own AI model of convolutional neural network. So how I can identify a particular person, maybe it will be through a identifier, like a model identifier will be there. You should have an input fingerprint like a data timestamp or a data hash should be there. You will have the output hash, and even you can have like a optional more complex zero knowledge proof. Like if you want to have a higher zero knowledge proof, that is also doable. But here it makes the individual AI decisions auditable and verifiable to the whole public. Like whatever decisions are being made, whatever components, everything will be written in on chain, and it will not reveal the model weights or raw inputs, because if you want, you can reveal, but it's not needed, because here the parameters are mostly focusing on what kind of model is being run and how people are actually going to use it. And how, as I mentioned, for each record, you will have the model identifier, the input fingerprint and output hash. Then you will have the evidence change with the ZKPs. Why you are going to use it? It supports accountability for the decision making, like primarily in the financial AI solutions or autonomous systems and the decision critical APIs, where you need to have some instantaneous decisions, say like whether you're designing an AI model which works on the Indian stock markets. So on the stock market, if there's an AI model, you need to have the right computation where to buy the stocks and where to sell the stocks, where to get the profit, or if there is a big crash happening in the share market, what is the immediate remedial step you have to take, something like that. So all these things should happen on chain immediately, because you will not be having too much of time to take decision, and you will not be having too much of time to load the whole data set and run something like that. So that is where we want to have such kind of inference attestations working with the on-chain levels. And the last one is the combination of the hardware, that is the TE, and the blockchain hybrid version, where which is mainly used for when you are having AI models which are running for the external hardwares, like if you are connecting some IoT devices or other cloud computing edge AI devices, some proprietary models like smart home appliances, smart devices, etc. You will have a hardware component plus the blockchain version, where you will collect all the evidences, and these will be stored on chain to notify this examples, or to notify this AI events. So here how it will work is the code will be working within the Intel SGX books kind of trusted environments, where you will have the hash of the code, the model version, and input output, and it prevents any kind of tampering, because you will have a blockchain hybrid version with uh, the trusted execution environment hardware. So there will not be any direct data set, or there will not be any direct cloud computing huge data set interaction, because these are like low power consuming devices, or even the real-time devices which need to work on a different protocol, not on the same blockchain protocol. Like the IoT protocols will be defined by the IEEE protocols. Edge AI will be again defined by a different set of IEEE protocols, something like that. So in such scenarios, we can even combine blockchain in a hybrid way. So these three are some of, I'm not limiting only to these three models, but these three are some of the most prominent versions in which people are trying to build the trust for the AI models, the data provenance, the on-chain inferences, and the hardware-based trusted execution environments. Beyond that, there are many other sorry, there are many other auditing happenings on the live AI model approaches, where if you're building a model, you will have the AI design studios, where within the design studio you can validate all these kind of audit trials, and you can build the solutions and try and test it out, and come back to run any kind of additional inferences that are needed for the AI models. So like this, there are a lot of other things happening, but just for your understanding and within the time constraint, we will see these three approaches out there. And finally, the provenance model, which I already mentioned. So what to record? It's mainly your choice. If you can record the whole data set source, the ingestion time, transformations, the label IDs, the model training, and the standards and manifestations. Mainly the data provenance and the model provenance, like whatever parameters are needed to prove the history of the data, as well as to prove the history of the model, is completely important. And finally, you will go for the evaluation provenance. So evaluation provenance, as I mentioned, if it is a pure business AI model, the business owner will be defining the evaluation provenance. Or if it is a research project, the researchers or the group of people who are the beneficiaries can actually define the evaluation provenance out there. And the last dimension which we want to focus is a zero knowledge proof. So there are now advanced algorithms which combine the zero knowledge proofs with ML, which is called ZK-ML, which enables the AI provider to prove claims about the model or inference without revealing the model weight, training data, and input features. So it's almost the same as ZK snark and ZK stark, without revealing the actual data, but they can prove the verifier learns that the claim is actually true and what can be proven. So mainly the inference correctness, the model properties, and the policy compliances. So if there is a specific output that was to be computed, it will have like a output mapping. Like with this particular input, you will definitely get this particular output. So irrespective of how many times you are running this model, you'll definitely have the input fingerprint, and this will definitely map on to the respective output mapping. And the model properties, obviously, you can compare the accuracy and threshold of a certified data set, which can be a test data from a trusted source, and you can also have the constraints being satisfied. Just like you are taking some trusted data sources like the KDD cup set and similar data sets, you can also do it with the model properties. And the policy compliances, as I mentioned, for any AI model to run in European Union, you have to comply with the AI for European Union standards, and the EU Act have to be validated properly. Then only you can have the approved model version to be used in the Europe. So that is how the constraints keeps into play. So ZKML is a vast topic. Like if you want to go deep into that, it can be like a whole different section. But I just want to, because I know most of you will be researchers out here. Most of you will be interested in AI, its security, its privacy, as well as combining the blockchain concepts on top of it. So if you're more interested in that, you can actually focus on the ZK proofs also. So with that, I will wind up this session because I know I'm